Hello and welcome to how to create a turntable part 3. In this video we're going to talk about the software and let's start right away. So I'm connected to the Raspberry Pi via SSH. Here we have the GUI. Here we have the model we're going to talk about. There's also a view with sensor data so here's what we are driving to, the radial position. Here we have a speed setting, so let's speed this thing a bit up. See, now we are going very fast. Oh, it's bright out there. So yeah, we're going very fast. Now we are going very slow. 20 is a good speed for me. So you can decide whatever you like. So let's talk about this model. We have BPIO for the stepper motor control. You see this is an old version. It doesn't have the I2C port. When I started this table a year ago or more than a year ago, and at this point there was no I2C, but now it is. So you could connect your sensors to the BPIO if you want to. Here they are now connected to the Raspberry Pi Direct. We have two sensors here, one with an alternate address, the other one not. And we take the magnet output, build the length, and this goes here to our input. The controller is basically the part of the program which converts the X and Y coordinates to the stepper motor outputs here and calculates the maximum speed, because in the center we have to be much slower, because you need a high speed to make a full turn and so on. So it also calculates the speed for the player, which streams the X and Y coordinates to the controller. So yeah, here's the parameter we just edited. Let's start right away with the controller here. So the controller has some parameters, inputs and outputs. And the parameters, let's look at my table real quick, what we have. You have to specify the ticks per round. So one circle takes 15,000 steps in my configuration, and in the radial position we have 20 ticks per millimeter. We have a radius of 298 millimeters. 300 will work too. I've adjusted this parameter, but 300 is good too. This was just a test. And here we set our levels for the magnet to for the calibration. So basically, when you want to do a calibration, you manually drive to the position that the magnet is direct above the screw, and then you look into your scope here and see the level at which you want to stop. Then you test it and it's fine. Let's speed this thing a bit up and see when we get the bump from the magnet in the angular direction. So this is all normal, and here we are. So this is how the table calibrates itself. Okay, so what else do we got? Yeah, maximum ticks is the maximum speed. So basically for the turning speed close to the center, this is important. Let's look into the code a bit. Here we have our tick function. It's basically the calibration steps we have. And when we are calibrated, we always call the calculate output. And in the calculate output, we take our inputs, X and Y, calculate the radius, calculate the angle here, and the rest is output speeds some limits here. So maximum angle here, maximum acceleration here, and here we are making that the start angle is only between 2 pi and 0. So yeah, that it's not winding up. Okay, so that's basically it for the controller. Let's look into the player. The player streams the X and Y coordinates here. It has an input for the speeds. It has a maximum radius that's needed for the theta row input files. It can read gcode and the theta row file format from the famous Sisyphus table. So yeah, you can download the tracks from the internet. You can make some yourself at sandify.org. There are a lot of tools you can use. So yeah, make yourself, download some. Yeah, exactly. So now where were we? We start here at the tick function. The player has an array of 2 points, and it goes down this ray until it's at the end. Then it calculates a next ray out of a points list that comes from the parser. So when we calculate the next ray and we are at the end of the points list, we load the next file. Now let's look into load the next file a bit. Here we are. It takes the directory, takes out a random file, and then parses this file. And when no, so here's the random command, and when there is no file found, it creates a random pattern, which is a straight line that goes through the center. So that's also good for testing. So let's don't look into the parsers. So here we have parse gcode and parse theta row, and the source code is also here. But I decided to not show this to you. You can look into this. It uses the famous X parser, and I'm using this for years, and I'd like to say something about it. It's a masterpiece, and I'm using it for years, and this G-code parser is really old. And yes, and I figured out that there is a new version, and this is basically all legacy code. And the new version is so much better than the old one. So I don't want to teach you the old one or the legacy code. When you want to make your own parser, I really favor X. This is such a beauty. This is the way how to make parsers. There is no other way. So I've used Flex, Bison, all this stuff, all these parser generators, lemon parsers. This is the way. It's a masterpiece. It's mind-blowing, like, yeah, when you first heard of design patterns or the concept of function objects and how to get from bottom to top instead of always going from top to bottom and so on. This is really good. So when you want to make a parser, look into this. Don't learn from my code. Yeah, that's it. So I hope you enjoyed it. I hoped you learned something, and when you want to use it, just add the parameters here and execute it. So thank you for watching, and bye bye.